Hey everyone, today we are going to learn 14.4 approximating square roots. Okay, so what are you doing today? I'm going to teach you guys two things. First thing, you're going to be approximating square roots, and then you will be classifying real numbers. Very easy stuff, okay? Very easy stuff. Okay, so how do we classify real numbers? So back when you were a kid, when you learned about numbers, when you started learning how to count, you learned your natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to gazillion, bajillion, bazillion, okay? And then when you grow older, you're like, oh, wait a minute, there's a 0? Oh, that's weird. There's an absence of a number. So all of these numbers are called whole numbers. It starts from 0 and includes all the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, all the way to a billion, okay? And then when you grew older again, you learned that there were numbers behind 0 on the negative region, right? There was -1, -2, -4, -12. These are all integers. And then last category, you learned that there were numbers in between these integers, like a half or negative a half or 0.1. These are all rational numbers. So just to kind of like summarize, all natural numbers are included in whole numbers, all whole numbers are included in integers, and all integers are included in rational numbers. And just to refresh your memory, all rational numbers, they either end, they are all terminating, it just stops, like 1 or like 3 or like 7 or 0.9, it just stops, it's a terminating number. Or there's some sort of pattern. If you guys remember, 1/3 is 0.333333. As long as there is a pattern, they are considered rational numbers. Now on the other side, these numbers right here are irrational. Okay, these are irrational numbers. This is kind of like pi or 7.41473, blah, 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 blah. It keeps going on and on and on forever without any pattern. If they don't have a pattern, they are called irrational numbers. And all of these numbers here, right? Oops. All of these numbers here, rational, integer, whole, natural, irrational, these are all part of real numbers, okay? Real numbers. Okay, so let's take a look at example number 1. Let's classify the real numbers. The first number that I have is 3. So what is this? Well, you can say it's a natural, it's a whole, it's an integer, and it's rational. Take a look at this one, -3.2. Well, this one is just rational because remember, rational numbers are like fractions or decimals, the numbers in between integers. 1/3, this is rational, right? Same thing, fractions or decimals. And then over here, you have square root of 17. Now, if you were to get out your phone or your calculator and you were to plug it into your, punch it into your calculator, that's going to give you some funky number like 4 point blah, 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 blah. It's going to keep going on and on and on. So we call that irrational. Pretty simple, right? Okay, let's take a look at part 2. How do you approximate square roots? So if I give you this question right here, it says, find the approximate of the square root of 50 to the nearest integer and tenths. So this is kind of weird because we don't know what times what gives you 50. I know you're thinking, oh, 5 times 10, Mr. Chen. Okay, that's great. But they have to be the same number, right? This number right here has to be some sort of like perfect square for it to come out to be like a whole number. Okay, so the thing that we know closest to this is, I don't know, like 49, right? Isn't that a perfect square, 49? And square root of 49, oh yeah, duh, that's just 7, because 7 times 7 gives you 49. And something that's a little bit higher, right, that's bigger than square root of 50, we can say, oh, we know square root of 64, right? That's a perfect square. Square root of 64 is going to be 8. So if square root of 49 is 7 and square root of 64 is 8, we know that square root of 50 has to be somewhere in between here. It has to be between 7 and 8. And if we just use our common sense, our logic, you see how square root of 50, it's a little bit closer to square root of 49, right? So our answer has to be 7 point something. It has to be a little bit bigger, like slightly bigger, probably like 7.1 or something like that. Right, so if we were to round square root of 50 to its nearest integer, it's going to be 7, or to the nearest tenth, it's around 7.1. And you can double check this using your calculator. Okay, let's do a couple problems and apply this this strategy here. Okay. Oh, that's my little thumbs up. Are we cool? Yeah. Okay. All right. Here's example number 2. Let's estimate the square roots to the nearest integer and tenth. Same thing that we just did in the previous slide. So we have square root of 17. Okay, so think of a perfect square that's very close to square root of 17, very close to 17. Got it? Yep, that's right, it's 16. So square root of 16 is going to give you 4. So my answer is going to be a little bit bigger than 4. So you can say the nearest integer is going to be 4, or to the nearest tenth is going to be 4.1. Again, use your calculator to double check this, okay? Let's take a look at letter B. Square root of 23. That's very close to, yep, you guessed it, square root of 25, right? 5 times 5 is 25. But you see this is 23. It's a little bit less than 25. So I know that my answer has to be around or a little bit less. So it has to be like 4 point something. If you punch it into your calculator, it's around 4.8. Okay, let's take a look at letter C. You have 80 right here, square root of 80. What's the nearest perfect square? That's 81. So it's around 9, right? Negative 9 or negative 8.9 because it's a little bit less than 81. And then final one, you have square roots of 102. What is very close to 102? Oh, it's 100. So 10 times 10 is 100. So our answer is going to be a little bit bigger than 10, right? So negative 10 or negative 10.1. Okay, is this okay? Cool? Okie dokie. All right, I'm having too much fun with all these animations. Here is example number 3. For this one right here, it says approximate the diagonal length. Yes, this is exactly what you're going to see in your homework. So this is a free answer for you, okay? So let's say I have this square, and I were to draw a diagonal length, just like that. Oh, Mr. Chen, I know how to do this. This is kind of like finding the hypotenuse for the Pythagorean theorem. Sure, yeah, it's kind of like the same thing. So I'm going to call this C, okay, because that's what you're, what you're familiar with. So I'm going to try to find this distance right here, C. What is that? I'm going to use the Pythagorean theorem. So I'm going to write down a squared plus b squared is equal to c squared. I know that my 6 and my 6 are going to be my legs, so I'm going to plug it in and try to find c squared. Easy stuff, 6 times 6, 36, 6 times 6, 36. Okay, let's kind of simplify this down. 36 plus 36, that's going to give you 72. Okay, breathe, we're almost done. Now I need to find out what c is, right? So we know c squared is 72, so the inverse operation of squaring is going to be square rooting. I'm going to square root both sides. So that's going to give me a square root of 72 is equal to c squared. And here we go. My answer is c is equal to square root of 72, but we have to approximate this. So let's think. What is a perfect square that is very close to 72? Yeah, you're right. It's 64, right? It's very close to 64. So square root of 64, we know that it's 8, right? It's it's going to be 8 times 8 is going to give you 64. And the number above 72 is going to be square root of 81, which is going to give you 9. So if you use your common sense, you use your logic, you know that square root of 72 is going to be somewhere right in between 8 and 9, right? And if you use your calculator, that's going to be 8.5-ish, around there. So you guys can say that my diagonal length is going to be 8.5 feet, approximately there, 8.5 feet. Okay, are we good with this? Yeah, rock on, rock on. Okay, here's the next one. Here's a little summary. So quick summary. Let's classify the real numbers. Okay, let's kind of summarize everything that we learned. So I have the number 8. Classify this. Oh yeah, that's a natural, it's a whole, it's an integer, and it's a rational number. Let's take a look at square root of 21. Is that a perfect square? No, it's going to give you some mumbo jumbo, blah, 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 some number that keeps going on and on. So that's irrational. Take a look at letter A right here. So we're going to estimate the square roots. Same thing. You have square root of 68. What's that very close to? Oh yeah, square root of 64. So square root of 64, that's going to be 8 times 8, right? So my answer is going to be a little bit bigger than 8, slightly bigger. So you can say 8 is the nearest integer, and then to the nearest tenth is 8.2. And then last one, square root of 120. That's very close to, yep, you guessed it, 121, right? That's 11. So we know that 120 is a little bit less than 121. So my answer is going to be a little bit less than that, right? So it's going to be a negative 10.9. Okay, that's it. I'll see you guys in the next video.